Have you ever wondered how electric charges interact? What makes them attract or repel each other? It's a fascinating world, the world of electric charges. Think about it. Every interaction, every movement is governed by these invisible forces. Like invisible threads, these forces either pull charges together or push them apart. And it's not random, there's a pattern, a law that governs it all. The answer to all these questions lies in a fundamental law of physics known as Coulomb's law. Coulomb's law, named after the French physicist Charles-Augustin de Coulomb, is a simple yet powerful law that governs the interaction between electric charges. But what does this really mean? Well, let's break it down. Imagine you have two charges. Coulomb's law states that the force between these charges is directly proportional to the product of their charges. This means if you increase the amount of one or both of the charges, the force between them also increases. It's like magnets. The bigger the magnets, the stronger the pull or push between them. The law also states that this force is inversely proportional to the square of the distance between them. So, if you increase the distance between the charges, the force between them decreases. But it decreases a lot faster than you might think, because it's the square of the distance that matters. You know when you rub a balloon on your hair and it sticks? That's static electricity at work, but as soon as you start pulling the balloon away, it falls off your hair pretty quickly. So, in essence, the bigger the charges or the closer they are, the stronger the force. And the smaller the charges or the further they are, the weaker the force. It's a delicate balance, a dance of sorts between charges and distances, all choreographed by the elegant simplicity of Coulomb's law. Now that we have a basic understanding of Coulomb's law, let's summarize the main points. This law, named after Charles-Augustin de Coulomb, has three key components that govern the interactions between electric charges. Firstly, the force between two charges is directly proportional to the product of their charges. This means the greater the charge, the stronger the force. Secondly, this force is inversely proportional to the square of the distance between them. In simpler terms, the closer the charges, the stronger the force, and vice versa. Thirdly, the nature of this force depends on whether the charges are of the same or different types. If the charges are of opposite types, the force is attractive, drawing them together. If the charges are of the same type, the force is repulsive, pushing them apart. And that, in a nutshell, is Coulomb's law, a simple yet profound law that underpins the interactions of electric charges.